In the previous class, you asked the question, what is the difference between circulatory motion and a rotatory motion? You know, in a rotatory motion, the object is at a fixed position. If you see the sarkha, it's a rotatory motion. Sarkha is not moving here and there. It is there. It is moving around a fixed axis. The axis is stationary. Here, the axis is stationary. So this is
stationary.
here. I'm coming to that. Here, the object is fixed. Object is as a whole not moving. But here, the object is the stone. The stone is the object. In the middle of the stone, is there any axis? No. There is not any axis. Here, the orbit. Moving around the sun. All the object is moving. But the earth has also a rotatory motion because it has an imaginary axis. That's why we get day and night. It has two motion, rotatory as well as circulatory. In rotatory, the object is fixed, and in circulatory, the object is moving. The object has a curvilinear motion. Okay, curvilinear motion is there. It follows a curve, but here it's not a curvilinear motion. It fixed. The axis is fixed. Okay, understood? What is circulatory and what is rotatory motion? Okay. Any doubt?
No.
Now discuss this oscillatory motion. To and fro or back and forth. A boy on a swing. The pendulum of a clock moving to and fro. Here is the pendulum. Similarly, the piston of a motor car. It's a very hard example because very few people see it, the piston of a motor car. The pressing cylinder of a juice machine, at a fruit seller shop, the piston of a spray pump, etc. all perform oscillatory motion. Vibratory motion. The oscillatory motion, it comes to its original position. Okay. In oscillatory motion, what happens? There is a translation. There is a translatory motion, but it again comes to its original position. This is called the mean position. If there is no oscillation, the pendulum will be here at A position. If you slightly displace it, towards B or towards C, it will come to its mean position. It try to come to its mean position. If here, it again go here, and the speed will reduce here. At the time it's 0, again it will follow the position of A. Okay. The pendulum is following the position of A. A is called the mean position. The swing also, it follows the mean position. When you swing, it goes and stop at a time. When you go from at a certain height, okay, have you seen that? At a certain height, it stop. It again come back to its mean position. So this is called oscillatory motion. Remember this. Vibratory motion. There is another kind of oscillatory motion in which the body does not move as a whole. That is, the entire object does not move. In this motion, a part of the body always remains fixed, and the rest part moves to and fro rapidly about its mean position. Look, in oscillatory motion, the whole body is moving. Here, the whole body, swing as well as the boy, is moving. Whole body is moving. But vibratory motion is also a oscillatory motion, but here the whole body is not moving. Look. Figure 2.13. Here is the 2.13. Shows a metallic wire stretched between points A and B. When the wire is plucked from the middle, it starts moving up and down rapidly. However, the motion is not oscillatory in nature because the whole string does not move up and down. Such motion is called the vibratory motion. It must be noticed that during this motion, a change in shape and size take place.
How a change in shape? They both are lines.
The both are line. Here is a straight line. Look at this, and here is a curved line.
But after the shaking stops, it will return to
It
its
will
mean
return
position.
to it. But here, have you seen any change in swing? Have you seen any change in the swing? Means is the length is increased or length is decreased? No, there is no change in size at all. Okay, and there is no here also. Is there any change of length in the pendulum? They are just moving here and there. Okay, length is same here. Look at this, length is same. So here also in A and B they are in a fixed position, but they are changing. When it goes up and down, then the length is increased here. What happened? The whole string is not oscillatory. The point A and B is fixed. A and B is not moving up and down. It's not it. Some parts of this where it's moving. A and B is fixed. So this type of movement is called vibratory. In mobile phone also there is the option of sound and vibration and vibration. When you switch on the vibration, the whole mobile doesn't shake. There is only a part there that shakes and we feel that vibration. So have you understood what is oscillatory and what is vibratory oscillatory? You can say like this. Yes, vibratory oscillatory. This is also oscillatory, but whole the body doesn't move. Okay? Any issue?
Nope.
Periodic motion. If you critically analyze the rotatory motion, oscillatory motion or vibratory motion, you will notice that all objects describing this motion repeat the motion after a fixed interval of time. There are three motions. They have mentioned three different types of motion here. Critically analysis the rotatory motion. Rotatory motion. Circulatory motion. And what is called vibratory motions. Three motions. These three motions, look at this blade move, again come here, again come here, here moving, again come here, again come here, here also earth, again comes here, again comes here. Vibration, this pendulum, it starts from suppose A, again comes to A, again comes to A. These three type of motions has a special characteristics. What is that special characteristics?
Periodic motion.
Repeat the motion after a fixed interval of time. Such a motion described by the object is collectively called periodic motion. What? After a fixed interval they repeat. Interval of time they repeat its motion. If the motion is such type, then it's called a periodic motion. Vibratory periodic, you can say that is a vibration and that is periodic.
So we can also say rotatory periodic.
Yeah, rotatory periodic you can say. Rotatory non-periodic. It is rotatory, but it repeats its motion not in a fixed interval. It repeats. Since it is rotatory, it repeats. Non-periodic means it doesn't repeat in a fixed interval. Maybe 1 minute, and sometimes it takes few more minutes, 2 minutes, sometimes take 5 minutes. It's rotating, but it is non-periodic. Understand what is periodic, what is non-periodic? Must be fixed interval.
So why is there a rotatory motion?
Yeah, rotatory motion has generally rotatory, vibratory. These motions has fixed time interval. Generally, like this hour hand, minute hand, second hand of our watch. So, but if there is some impedance, there is some obstruction, some frictions, varying friction, then you'll not get it after a fixed interval of time. Okay. A repetitive motion which repeats itself after a fixed interval or regular interval of time is called the periodic motion. Examples of periodic motion: the piston of a motor car engine running at a constant speed. This is also a vibratory motion Okay, vibratory periodic. The swinging pendulum of a wall clock. The needle of a swing machine running at constant speed. Hmm. Heart of a normal resting person beats 72 times a minute. A normal resting person, it's 72 times. If you do workout, then the heartbeat goes up to 140 times a minute. So it is a periodic or non-periodic?
Non-periodic.
Non-periodic. Heartbeat is not a periodic motion. You can feel it. Sometimes it's average 70.
Examples of
Yeah, examples of this. Generally, it considers 72 times. 70. But if you see yourself at a fixed time, sometimes it beats more than 72, maybe 90. Sometimes it beats 60 times a minute. When you work out, it goes up to 140 beats per minute. So it's a non-periodic. But on an average, 72 times a minute. So it's a very good example to understand periodic and non-periodic. It is an vibratory motion or oscillatory motion, heartbeats. Oscillatory motion. It's not an oscillatory motion. If it were oscillatory motion, the heart will come out of your body again and come to that part.
Isn't that how the heart beats up, down?
Up, down. It's an vibratory motion. Oscillatory motion, the whole body has to move from its mean position. Heart doesn't move from its mean position. It doesn't come out from your body. It just mean position it just shrinks and expands. Understand? Heartbeat is vibratory or oscillatory? Vibratory, because the whole body does not move out from its mean position. Here is the mean position. The body moves out from here. Here, come out from here. Vibratory, the main part is there. It's vibratory. The whole part is not moving out from the mean position. Okay. And the motion of a swing, periodic. The movement of lungs during breathing. Okay, it is a periodic movement during breathing. During breathing, look at this. Breathing also, it's not a periodic motion. Okay, breathing, you can breathe fast, you can breathe slow. If you are sleeping, then you're resting, your breathing will be slow. If you are working out, if you do some work, then breathing will be fast. Non-periodic motion. There are a number of situations when an object describes a repetitive motion. It is repetitive, but not at fixed interval of time. Such a motion is called non-periodic motion. A repetitive motion which repeats itself but not at fixed interval of time is called non-periodic motion. Okay. Examples of non-periodic motion. A football player running in the field up and down is performing non-periodic motion, as sometimes he runs fast and sometimes slow. It is not a fixed motion. Number 2, when the brakes are applied to a moving vehicle, the motion described by the wheel is non-periodic. It's a very good example. I am running my car at speed 80 km per hour. The wheel is moving. When you apply brake, the wheel stop. The time takes the wheel to move a complete rotation will not be same. So I have given some other examples, so it's okay. Motion of a bouncing ball that is under the influence of air friction and gravity. When you fall a ball, it will go down and again it will come up, again go down and again it will come up. It's a periodic motion. But here it is not a periodic motion because there is friction, air is there, gravity is there. Okay, it's not actually gravity, it's friction. Gravity doesn't play any hindrance to the bouncing of the ball. It's only the friction. It should be the friction only. The air frictions, it stopped the ball bouncing in a fixed time interval. Okay, if there were no friction, the ball will bounce in a fixed period, and that will be a periodic motion. Understand?
Then wouldn't gravity act?
Gravity, just it's a force pulls the ball towards the earth. Okay, and again it will bounce back with equal intensity, with equal force. It's the air that affect the motion of the body. Random motion. An object which suddenly changes its motion from one kind to another kind is said to have a random motion. For example, take a balloon and fill it with air. Notice the motion of the balloon as the air expels from it. The motion possessed by the balloon is said to be random motion. You cannot define a balloon. When you expel the air, just leave the tip of the balloon, it will move like that. It's not a periodic, not a oscillatory, not a vibratory. You cannot define the motion of the balloon by this 7, suppose 6, not 6 actually, up to 5. Describe the motion of the balloon with any of this definition. So this is a random motion. Flying mosquito, a flying kite, and a motion of football or hockey player on the ground are some of the examples of random motion. All these objects have no specific path and they change their motion suddenly. So their motions are said to have a random motion. Uniform motion, yes. In an ant moving along a straight line towards east. This is east. Such that it covers distance from A to B, suppose A to B 2 centimeter in 1 second. Okay. Similarly, it moves distances BC, CD, DE equal to 2 centimeter in every 1 second in a straight line. In such a situation, the ant is covering equal distances in equal intervals of time along the same straight line. When a body covers equal distances in equal intervals of time, equal distances in equal intervals of time along the same straight line, the body is said to be describing uniform motion. 3 conditions are there to be uniform. What are the 3 uniform?
Same interval of time, same distance, straight distance.
Straight line. Covers equal distances. A body covers equal distances in equal intervals of time. Equal distance, equal intervals along same straight line. If these 3 conditions are fulfilled, then it's called uniform motion. Okay. So what do you think? Rotatory motion is a uniform motion or not?
No.
No. Why?
Not in a straight line.
Not in a straight line. It's periodic, maybe periodic. It equal distances in equal intervals. If you consider the fan, look at this blade. It travels equal distance at equal interval of time, but not in a straight line. So it's not a uniform motion. Okay. Similarly, a flying aeroplane in a particular direction at a constant speed, a train moving straight in a particular direction at a constant speed are describing uniform motion. Non-uniform motion. Imagine an ant moving along a straight line towards east, such that in the first second it covers a distance AB is equal to 3 centimeter. First second it covers 3 centimeter. The distance BC is equal to 2 centimeter the next second, and the distance CD is equal to 5 centimeter the next second. First second 3 centimeter, second 2 centimeter, then 5. In third second 5 centimeter. You can see that ant is covering different distances in equal intervals of time in a straight line. Such a motion described by the ant is non-uniform motion. When a body covers unequal distances in equal intervals of time along the same straight line, the body is said to be describing a non-uniform motion. There are 3 conditions. Here, it's not fulfilling the first one. Not traveling equal distance. Equal interval is okay. Okay, first, second.
Yeah.
If one condition is not fulfilled, that is enough. It is not a non-uniform motion. Similarly, a cyclist cycling on a busy street is describing a non-uniform motion. When the brakes are applied to a fast-moving car, it describes a non-uniform motion.
So
Okay.
what about the time when the brakes were not applied?
Yeah, and that may be uniform speed if the road straight. It's a uniform motion. Simultaneous motion, not. In some cases, the motion of rotation and motion of translation occur at the same time. Yes.
Translation?
Look, when a
You
drill
mean from Hindi to English?
translatory motion, what you have come out from the physics. Translatory motion. Translatory motion means translation. Okay, translation, you have used this word in only language sense, change of language. But translation means, actually translation means is here translatory motion. Okay, both motion. Yeah, here's look. Even in the definition also they have mentioned it. Rotatory motion, oscillatory motion are called periodic motion. Here, oscillatory motion is also a vibratory motion. So there may contain more than one motion, one type of motions. What? When a drill cuts through a metal pipe, it performs the motion of translation as well the motion of rotation at the same time. Is not it? It's the drill machine is rotating, and also it's penetrating this wooden plank. So it's also translating, coming down, isn't it? So both motions are there. Similarly, the ball delivered by a spin bowler describes the motion of a translation as well as the motion of a rotation. So you'll not understand this when we throw a ball. Here is not a, we don't have a ball. Okay. Other example of this kind of motion are wheels of a moving bicycle or a scooter or a car or a train. When an object possesses two or more types of motions at the same time, then that motion is called simultaneous motion. I told you the example of wheel. The wheel has two types of motion. One is translatory and one is rotatory, not circulatory. It's a rotatory motion. It's not circulatory. The wheel has a fixed axis. The wheel doesn't move around the car. It remains stationary with respect to car.
But what if you just leave a wheel on its own?
Then also it has translatory and circulatory. Not circulatory, it's rotatory. Suppose this is a wheel. Okay. It is moving in a straight line. Okay, it's come to here. It has two types of motions. One is translatory, come A to B. And then it's moving also. It's a rotatory motion, not circulatory. Suppose why circulatory?
It's not moving in its own place.
No. Why? What is the condition to be circulatory? It has to come to its original position. Will it come its original position?
If we are going to push it back.
Push it back. This will become a circulatory, no. Fixed point. Suppose consider this wheel A, position A. Now suppose the road is like this. Understand? Now it has a circulatory motion because it will move. It has now a rotatory as well as circulatory. Rotating here and again it's moving this again come to this position.
So what? So it's not translatory?
It is not translatory because it's coming to...
Then there is no translatory motion in the roads because the earth is a sphere?
Earth is a sphere,
so
translatory motion. There is, if you consider suppose this point to this point. Suppose wheel comes to this point. Consider this part, then it is not a... Is it circulatory? No, B is not point, but it is a translatory. Now here it is a translatory motion. Now if you consider the whole part, then it will become a circulatory part. So it's depending upon the situation. Okay. We have to consider the situation and accordingly we have to define the motion. The distance of a point of the body from a fixed point always remains the same in rotatory and circulatory motion, while it is not the same in curvilinear motion. Okay, understood what they say? In rotatory and circulatory
So you
motion.
said to me that example of that wheel going around, that it can't be a circulatory because only this distance is covered, so it's a curvilinear again.
It is a curvilinear. Okay, if you consider this part, it is a curvilinear.
Then it's not transient.
Sorry, it's not a translatory motion. Actually, it's a translatory motion. Curvilinear and rectilinear motion is a part of translatory motion, is not it? Here, translatory motion, rectilinear, it may be rectilinear, it may be curvilinear. Okay, it's a translatory and it's a curvilinear, not a rectilinear motion. Okay? Okay? Confusion?
No.
You just studied one and make a sort like this, like this, translatory, next coming rectilinear, linear, next here is curvilinear. Okay, make a chart of this and show me. Okay, it will improve your knowledge and understanding too. Here, what the distance of point here, the blade is always at a fixed distance from the axis. The stone is always at a fixed distance from this hand, this point. Here is the point. Okay. The axis of rotation passes through a point in a body itself in a rotatory motion, while the axis of revolution passes through a point outside the body in a circular motion. This is a more exact way to express the difference between circulatory and rotatory motion. Here the axis itself passes through the body. Here the axis not in the stone, outside the stone. Understood?
But
stone is different part.
But if we take a sponge ball or something, we can insert a thread inside and still we can do that. We can put it inside.
Thread and sponge are two different things. And this ceiling fan, this is the important part. Without this, the ceiling fan is not complete. It is an essential part of that object. Understand? Ball is itself in an object. The rope is not a part of the ball. So the axis is outside the stone or ball. Here the axis is fixed. Here the axis is fixed. It's an essential part of this body. Sarkha, it's an essential part of the axis is essential part. The axis is inside the body in case of rotatory motion, and in case of circulatory motion, the axis is or the point is outside the object, outside the body in circular motion. This is an important difference. Probably there will be some questions on this. Hope you will write it well. Understood? What is circulatory and perfect? Okay. Hence, the motion of Earth about its own axis is rotatory motion, while the motion of Earth around the Sun is a circulatory motion. Okay. Understood? So we have completed the first part, different type of motion. Do the exercise. Okay. Next class we'll discuss this exercise. Thank you.